that can happen in bacteria. It's also the perfect opportunity to illustrate a process that usually takes a very long time to see: natural selection. Now let's explain a basic example of natural selection. Consider these frogs sitting on logs in their habitat. Now let's assume that these are the same species of frogs, so they can breed with each other and they pass down their DNA to their offspring. And naturally, there is variety in these frogs. Some of these frogs are darker green, maybe almost a brown, and some of them are lighter green. There is a variety of traits even in the same species, just like in people. So back to the log. You know what else is in this habitat? Predators. And the predators are finding here that the lighter frogs are much easier to see in this habitat than the darker frogs. So in this particular environment, the darker frogs are having an easier time surviving and potentially more fitness if they can breed. Fitness, in the biological sense, is determined by not how long they live, but by how many offspring they have. These darker frogs pass down their DNA to their offspring so that the new baby frogs will have the DNA from their parents. And the lighter frogs are being selected against, since they're easier to see in this habitat. Now, over a long period of time, you could expect to see a higher frequency of darker frogs. If it continues for a very long time, it could even result in all the frogs in this area being darker. Evolution, which is change over time, could take place because natural selection has occurred. Natural selection is a mechanism of evolution. And one thing to point out, it doesn't necessarily mean that the allele for lighter color is gone completely. The allele could be recessive and carried within the population. And because of processes like crossing over and mutations, there are opportunities for variety. But if this habitat and predators do not change, then the darker frogs will continue to have more fitness. Now, we want to point out that variations and mutations are not things that an organism can will itself to have. Frogs can't just think, it's better for me to be darker, so I'm just going to have some variation to be darker. Because if that was true, well, let's just say I might be a bit different. Mutations and variations, they are random. It's possible they might not have any effect on an organism's fitness. So in that case, the genes are to be passed down if the organism happens to be able to reproduce. Or variations and mutations can be negative. If they are negative and negatively affect the organism's fitness, meaning no babies, well then that trait will not be passed down. But if they have a positive effect on the fitness, then that frog may have more babies than average because that trait is helping them survive and reproduce. It's an adaptation. And over time, there will be more babies with those genes. And over time, that trait that is an advantage will be more frequent in the population.